Good day everyone. Welcome to this webinar series 3D Print in 19. I am Ng Kwan Ting, Application Engineer in Ultimaker Asia Pacific. And with this webinar titled Master Ultimaker Cura Basics in 19 minutes, I will share with you what are intent profiles and the various applications they are used for, how to use per model settings, and some possible usage scenarios, and cover the key settings you will need for your dual extrusion prints. Discover the power of collaboration in the Ultimaker marketplace, offering the widest range of materials from our Material Alliance partners and integration for the world's leading CAD software solutions. And of course, there will be a Q&A session for you to post your questions. Let's start. Before we dive into the technical how-tos, I would like to give a short introduction of Ultimaker Cura. Trusted by millions of users, Ultimaker Cura is the world's most popular 3D printing software. Users can prepare prints with just a few clicks. They can also integrate computer-aided design software, or CAD for short, for easier workflow or simply dive into custom settings for in-depth control. At the heart of Ultimaker Cura is its powerful open-source slicing engine, built through years of development by our experts and user contributors. It's amazing that Ultimaker Cura users worldwide prepare over 2 million prints per week. Print slicing with our open source software, Ultimaker Cura, grew 124% in 2019, while G-codes for Ultimaker machines grew 40%. The total number of users per month nearly doubled. At this rate, we expect there will be more than 90 million slices this year. Ultimaker Cura was awarded the Software Tool of the Year award from the 2019 3D Printing Industry Awards. Last year's annual event in London saw the attendance of more than 150 guests, representing over 60 companies in both desktop and industrial additive manufacturing. A big thank you to all who voted for Ultimaker Cura. Although Ultimaker Cura supports multiple third-party 3D printers, its full functionalities are brought out when you use it together with Ultimaker 3D printers. One of these functionalities is the set of test and optimized print profiles. Ultimaker Cura gives you access to over 400 parameters across 13 sections via the custom print settings button. With this, you have almost unlimited control to adjust and improve your print quality for any 3D printer. Of course, changing and testing even a few of these settings takes time. For busy engineers and designers, this is where pre-configured material profiles become a big time-saving feature in Ultimaker Cura. Print settings profiles are the result of Ultimaker's effort to make the 3D printing process simpler and more reliable. And now we have taken our profiles to another level: intent profiles.
When you're 3D printing for business, finding a balance between speed and quality can be a challenge. And when you have tight production deadlines, playing with settings and running test prints isn't an option. That's why we've introduced a substantial improvement to our slicing workflow in Ultimaker Cura: intent profiles. Whether your intent is speed, accuracy, or visual quality, spend less time configuring settings and more time innovating. Intent profiles show the true value of 3D printing and will speed up adoption within your company by simplifying the print preparation workflow, saving significant time, and producing the results you need for a wide range of applications. Print quick iterations of your initial prototypes, visual concept models, or parts with strict engineering tolerances, all at the click of a button. Here's how it works. Start by loading a 3D model on the build plate. To do this, you can click the Open File button at the top left corner of the screen, or you can simply drag and drop your model onto the build plate. Intent profiles are available for common configurations. We'll use an Ultimaker S5 loaded with tough PLA and PVA with 0.4mm print cores. Open the Settings panel to choose a printing strategy. Available intent profiles automatically show below the default profile. To print parts with high-quality visual characteristics, use the Visual Quality profile. To print very accurate models with tighter tolerances, use the Engineering profile. To print designs in the shortest time possible, use the Draft profile. The software will automatically configure all the necessary settings to suit the intent. We want our initial prototype printed quickly, As the default profile isn't intended for quick results, the print will take significant time to finish. As a solution, let's try slicing with the draft intent profile. Already you can see that using this intent profile has cut the print time significantly. All we need to do now is hit print. By using the draft intent profile, we can validate the concept faster, accelerating your product development cycle. That's it. We've prepared a print using an intent profile.
For more information on the benefits of each intent profile and configuration compatibility, please visit our Ultimaker support page and search for intent profiles in Ultimaker Cura. Each intent profile works best with the Ultimaker S5 Pro Bundle, Ultimaker S5 and Ultimaker S3 when used with our range of Ultimaker PLA, Ultimaker Tough PLA and Ultimaker ABS materials, as well as compatible support materials like Ultimaker PVA and Ultimaker Breakaway. As of now, the intent profiles are available for the 0.4mm nozzles only. In the latest Ultimaker Cura 4.6.1, we added engineering profiles to more of our material portfolio: Ultimaker CPE, CPE Plus, Nylon, and PC. One of Ultimaker Cura's most powerful features are located in the adjustment toolbar, the per model settings. This set of tools allows you to modify the way your 3D models is printed and enhance the outcome of your printed parts with a click of a button. Let's look at modify settings for overlaps. Instead of printing the STL file as a solid model, with the printing strategy visible in the print settings panel on the right side, it will modify models it overlaps with. Using per model settings, you will be able to print the infill with a different material type, a stronger PC or CP Plus for example. Do this by simply loading a different material into Extruder 2 of the machine and configure it in Ultimaker Cura. 2. Print an infill with the same material but with a different infill density. For this simple demonstration, I will start off with a simple cube, 50 by 50 by 50 millimeters cube. And then after this demonstration, I will give another demonstration using a model that we will more likely to use the setting in an actual application scenario. But to explain the concept to you, I will use a simple model for now. So I have Ultimaker Red Tough PLA assigned to Extruder 1 and Ultimaker Green Tough PLA assigned to Extruder 2. And for this cube, I have chosen an infill density of 80%. I've assigned this to Extruder 1. Let me start off by selecting a support blocker and putting it on the cube. I will select the support blocker by either clicking it or selecting it using the object list. Next, I would scale this support blocker and move the support blocker so that it covers roughly half of the cube's region. Next, I will assign Extruder 2 to the support blocker and go to Per Model Settings, click on Modify Settings for Overlaps. On the right, under the Print Settings panel, I will configure infill density as 1%. Let me slice. And in the preview mode, you can see that on the left half region of the cube, as I slide the slider upwards in the layer view, you can see that this is printed with 1% infill density, while on the right this is 80% infill density. You can also see that the infill is being printed with Green Tough PLA. Now if I want to print the infill with the same color, then I click on the support blocker, assign Extruder 1 to it, and then click on Select Settings, and when the window appears, check infill density, close the window, and let me just put it as 1% again for demonstration purpose. hit enter, click slice. Again, in the preview mode, under layer view, you can see now that the left half region of the cube is being printed with 1% density at the same color. In this next demonstration, here I have a tubing, and you can see that the narrower part of the tubing could be connected to something such as a tap or a pipe, depending on your situation. And I have a broader area of the tubing. Now, let's say that I want a tighter fit to either the pipe or the tap, or whatever that I want to connect this tubing to. So I have to have this upper region, the narrower part, with a higher infill density, and I would prefer to have more flexibility in the lower region of the tubing, the broader part. So let's start off this demonstration by configuring this. As you can see, I have put it as red TPU. TPU 95A is the material I've chosen to print this material, and I've chosen to configure the infill density as 10%. Now, what would I do to modify the infill region for this upper half of the tube so that it has a higher infill density? So first off, like the previous demonstration that I did, let's put a support blocker on it. Select the support blocker, and I will scale it. Move it. You can always scale it larger. I'll make it overlap with the upper region of the tube. Next, I will go to Per Model Settings, click on Modify Settings for Overlaps, and because I want the region to be printed on the same material, I will not assign this to another extruder, but I'll stick with extruder 1, and then I'll go to Select Settings, scroll down to find Infill Density, close this window, and for demonstration purpose, let's say we put this as 40%. Hit enter and slice. In the preview mode, you can see that this is at 10% infill, and when it reaches the overlapped region, this has turned to 40% infill density. Let me do this again by scrolling down and sliding upwards again. This is 10% infill density. As I approach the region where it overlaps, you can see now that the infill density is at 40%. And that's one example of how we would use this setting in a real life scenario. When selecting cutting mesh, you will notice there are no default options turned on to alter its behavior. This is because the cutting mesh option prints the entire overlap with 3D model with the altered settings. This allows certain parts of your model to have a different printing strategy completely, or even be printed in a different color or material. The options available for the cutting mesh are identical to the infill mesh. Parameters of the extruder it is printed with are used, and the select settings can be used to add additional changes. In this simple demonstration to show you modify settings for overlaps cutting mesh, I have a manufacturing tool here, which I have configured with the Ultimaker Green Tough PLA on extruder 1 and Ultimaker Black Tough PLA on my extruder 2. To show you just a simple example of how to use this setting, I have a support blocker I created here, and I have assigned it to extruder 2. And of course, I will have to click on Per Model Settings and Modify Settings for Overlaps and choose Cutting Mesh. Next, I'll drag this to cover a region of my manufacturing tool, and I'll slice it. In the preview mode, preview tab under layer view, you can see now that the left side, the left region of my part is now printed in the black tough PLA. For more information on how to use the various adjustment tools, simply visit Ultimaker's support page, click on Software, Ultimaker Cura, using Ultimaker Cura, and you will find many great articles there to help you to learn about the adjustment tools in Ultimaker Cura. Owning Ultimaker 3D printers such as the Ultimaker S5 or the Ultimaker S3 empowers you to do dual extrusion prints. Shown here are 3 dual extrusion possibilities that most people will be familiar with. 1. We can print a build material with one extruder and using the second extruder for a support material. 2. We can print a model in 2 different colors. And 3. We can print a model in 2 different materials. The possibilities that dual extrusion offers are actually much more, such as printing parts with complex geometries, do color coding on all parts, for wear indication to reduce downtime in the production line, combine a wear-resistant material with stiff material in a part, for having text and to have a hard and soft material combination in a part. In this example, a model is loaded and configured to be printed with extruder 1, red PLA, but the outer wall extruder is configured to use nylon as seen here in white. One of our customers created this model to push cans out of a conveyor belt. The purpose of changing the outer wall to print with extruder 2 white nylon is to have a visual indication to replace the part. When the white outer wall wears down, the red is going to show, and that indicates this part has to be replaced in the production line. Imagine, without this visual indication, when the part does eventually wear off and breaks, production will be halted. This unexpected downtime will cause loss of time and money. Next, I would like to talk about Ultimaker Marketplace. Our Ultimaker Marketplace is adding true value by allowing you to tailor your 3D printing experience with plugins and print profiles. This results in optimized and custom print preparation and unlocks applications. I would like to use this video to show you a short introduction of the Ultimaker Marketplace. To access the Ultimaker Marketplace, simply go to in Cura, click on Marketplace, or similarly, you can also open up your browser and enter marketplace.ultimaker.com. Now you will see 2 categories, plugins and materials. For this video, I will show briefly what plugins we have. I would like to also briefly explain our settings guide plugin. Here in the featured plugins, you will see plugins for the major for 3 very well-known 3D CAD softwares. We also have a very useful mesh tools plugin here. If you scroll down, you will see community plugins. I encourage you to check them out and see whether you can use them to enhance your 3D printing workflow. Now let me click on settings guide. You can see that this is a guide on what settings do and how to use them. So once you have the settings guide installed, go to extensions, settings guide. You will see that it is a guide that is very comprehensive, that explains each setting. So taking for example, if you click on a setting, you will have a very detailed article and some pictures to explain to you what a particular setting or parameter is and what are the effects it will have if you alter that parameter. If you scroll right down, you also have a very useful troubleshooting section that explains to you what are some of the printing artifacts that you will face and how to resolve these printing artifacts. At any point of time, if you have difficulty understanding a particular setting or parameter, simply just right click on settings guide, and the settings guide will appear and you can read the article about it and take advice from there. Next important component of the marketplace is the materials section. With an open material system, the Ultimaker Marketplace unlocks materials with a wide range of properties to fit any application. Whatever your material requirement is for the application you seek, Ultimaker helps you to unlock and enable the right material for it. Through our third-party material program, material partners offer optimized print profiles through the Ultimaker marketplace. And as these print profiles are developed and tested by partners, users have a streamlined workflow and a very high 3D print success rate. To end this webinar, I would like to show you how to save a Cura project file. So what is an Ultimaker Cura project file? Ultimaker Cura contains a lot of information about the printer and its configuration, the loaded models, model adjustments, and print profiles. Saving all this information is possible in the form of a project file. This file contains the following information: printer settings, extruder settings, profile settings, post-processing scripts, if any, 3D models, and a thumbnail. We recommend saving your projects directly after sending it to your Ultimaker 3D printer. This way, you ensure your saved project contains the exact same information as your print job sent to the printer, which includes the printer configuration, model adjustments, and print profile. Simply go to File, Save to save the project file. It's time for questions and answers. If you have any questions, please type them into the chat box and we will try our best to answer them. Thank you.